Sure, why not?
That's not from here.
That kind of sour.
So, take some tap and come away.
No, I got nothing. Let's do it. No, I'm good, thanks. I don't mind. I'm good.
Yes, go.
I don't like Coke. I only have Coke like maybe.
Same fucking.
No.
No.
Yeah, actually, maybe like this.
We call it a Coke, but it could be something else.
No. I don't. I used to like Coke, but I think it's too sweet. So it's just tea and coffee.
Did you do the color from sandwich today?
Huh?
Yeah, about this today.
No, actually, I didn't.
Today?
No.
You don't drink?
I do, but not that much. Maybe.
You like the lunch?
Yeah.
After the, like 50 days, no, after 48 days, you and I can go. Then it's Karawan.
Milano?
Yeah.
Cool.
On me.
No.
Don't be done with the pizza, please.
It's Italian restaurant.
Yeah.
Pizza and something.
Oh,
Because I eat halal, I would eat like this plain pizza with the chicken and stuff.
They have halal? Probably not.
No.
No, I wouldn't have thought so.
What was your stuff?
I'm a VIP
Milano?
customer over there.
You're what?
I'm a VIP customer there.
Monday on Sunday.
VIP customer?
Yeah.
Let's see now. Very,
I have a card there, VIP customer card.
very, let me see how I can finish this now.
But that's the
Don't make
Very interested in physics?
Because of physics, they give me 25% discount every time.
Because you're a very interested in physics student, they gave you 25%. It's not bad.
That's why I want to, take you there.
Oh, yeah.
Use physics.
I'll have that 25% free part then. That didn't cost you anything. Right, okay, so we're going to continue with vectors. So what we're looking at now with vectors is a vector base. Yeah, page 70. Yeah.
Yep.
So, previously we've seen two ways to use vectors. We can, well, three ways. We can draw it simply like this, yes? Or by using points, we can define it by using points. What's the name of that method when you use points to define the vector?
point vector.
Goodness, no.
Euclidean.
This is Euclidean vector.
Position vector.
Yeah, and then the last way we can define vectors is by using a position, as a position vector. Although these are kind of inconvenient because it requires a drawing, right? So what we're going to do now is use two special vectors called I and j, which are basis vectors. So we define I, we have O, we have I, we have j. So I is defined as a 1 unit horizontal position vector, and j is defined as a 1 unit vertical position vector which is perpendicular to the I. So, to be clear, the magnitude of I is the same as the magnitude of j, which is 1 unit. And also that vector I is perpendicular to vector j. And normally we draw I along the horizontal and j along the vertical. But I'm sure you've seen this before.
Yeah.
In high school or high school maths, high school physics. Any vector can be written in this form. So for example, I draw any vector I want, So let's say I just put a vector randomly over here. You can say, well, this vector is equal to 2 I vectors plus 1 j vector. So this vector here would be 2 I vectors plus a j vector. 2 to the horizontal and 1 to the vertical. Can you see that? Yeah?
And you're saying what?
This one. So you can write any vector in the form of so many i's plus so many j's.
How do you write 2j I?
Oh, I just visually estimated it.
No, I mean this. Okay, 2j.
Yeah? Does this make sense? Yeah? Okay. So, I'll give you a minute here. So here is the vector or is equal to xi plus yj. And let's draw it here. There it is, vector or. So first draw this, please. You got that?
Yeah.
Now what I want you to do, I'll give you 2 or 3 minutes, is I want you to try and find a formula that gives me the magnitude and then the direction here. Now you can do a little proof, okay? Right. So I want to get a picture for you while you're doing that.
Related to I actually.
Yeah, x and y.
X and Y.
Find the magnitude in terms of x and y. Oh, sorry, and, well, not that it matters, but I don't want to use theta, I want to use this symbol, phi, although that's not important. I want the magnitude of or in terms of x and y. Oh, definitely.
But we don't have X and Y.
Yeah, your answer will have x and y in it. Got it?
Just the direction. No, just calculation. We got the magnitude.
Cannot find a good picture to show you. I'll have to. Okay. Right. So what did you get for the magnitude for or?
X plus Y.
No,
X square.
that couldn't be more wrong.
X square plus y square.
Not quite. Almost.
At I
Square root
squared
of x squared plus y squared.
r squared. Okay.
Yeah, that's not what I wanted. I didn't want r squared. So here, kj, you did the thing which, oh, never mind. So, this here is xi's, and this one here is yj's. So, how big is this? Well, I is 1 unit. So you have xi's, and this here will be x units. And this one here will be y units. So, by using Pythagoras, you can get the magnitude of r is the square root of x squared plus y squared. And the angle will be what?
Tan yj over.
Tan inverse y over x.
Yeah. Okay. Yeah.
No I and j indeed. Okay. Did you get those formulas? If not, write them down. Okay. Now, I want.
But you didn't get it.
No, I did not. I want to find a nice 3D picture. Yeah. Maybe I'll get it here. No, that's 2 dimensions. I want 3
You want to go
dimensions.
home early today?
Everybody does, of course. For goodness sake, where is 3 dimensions? All right. That is 2 dimensions. 2 dimensions, 2 dimensions, 2 dimensions. Oh, for goodness sake. 2 dimensions.
YouTube it.
No, I want a nice picture of 3 dimensions. 3.
Take your time.
Spherical, not polar, that's the problem. Ah, beautiful. Now we're talking. That's a good looking 3D graph. So, we can do vectors in 3 dimensions. It's no big deal. Instead of having I and j, you have I, j and k. So, we'll draw it like this. We'll have the I vector drawn this way, the j vector drawn this way. It's not the way you might expect it drawn. The I and j are lying on the ground. And the k vector pointing upwards, like this. So for example, this vector here, if I try and draw it, let's see, let me try and draw 2i plus j plus k. So there's 2i, there's j, can you see that? Kind of using on the ground, and then here is k, 1k, so k going up. So it kind of you can't quite see because I can't draw in 3 dimensions, but it's pointing towards you, for example. And here's a nice picture. X, Y, and Z are I, J, and K. So your formulas are still the same though, slightly altered. So the magnitude here is not square root x squared plus y squared. What do you think would be? X squared plus y squared plus z squared. Now, the thing is this. Look at this graph. You have 2 angles now. So you see this angle here, phi, the formula you have. That formula is still the same, but that's only the angle between, on the xy, on the ij graph. Okay? So that formula is still tan inverse the y part over the x part, if you can visualize that. That doesn't change. So we still have phi is tan inverse y over x. But there's a second angle, and it's the angle that is made between the vector and the k-axis. Can you see that? So it's this angle here. Yeah? Now, I suppose there's a couple of different ways to do it, but one formula would be, what is this is the hypotenuse. If you draw a triangle here, can you see?
Yeah.
So what's the hypotenuse? Well, that would be the magnitude of r.
Yeah.
You also know the z.
Yeah.
So we have the adjacent
Where
and we have the hypotenuse.
Where is the side?
It's the length here. It's how far you go up. It's the length here, the height. So this is like the x part.
It would
This
be
is
given.
y part, and this would be z, huh?
It will be given.
Oh yeah, definitely, yeah. So if you have the adjacent and if you have the hypotenuse, what could you use? Cos, yeah. So if you want a formula for the angle it makes here with the, I can't draw it, with the k axis.
Wasn't it the same with the, if you show it angle with the J and K and the I and K?
What? So down there. This angle here
Yes.
is made with the z.
Yes.
Yeah.
Then is it not the same with the angle at the other side?
This one?
No, 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 no. I know there's one on this side.
Oh, one between this and the ground.
Yes, and the other side.
Oh, here.
No, like this is the line.
Yeah.
These are the two things here.
Yeah.
Like no, look at this is my the head.
Yeah.
These are the two angles, like the angle here and the angle here.
But why is there two? There's only one vector. Do you know what I mean?
Oh, yeah.
So this here would be cos inverse z over the magnitude. Cos inverse z over the magnitude.
But this will be changed or not?
No, this is the universal way to draw it. We have I, j, and k. And the phi is measured between the I and j, and the theta is measured with the z, the k. Yep. To this, the formulas.
We are practicing the ritual that great started.
eating
Yeah.
and drinking Coke.
Eating in the class.
On this figure.
Huh?
On this figure, do you have Z?
We do. It's really hard to draw, but the z is the theta is here, the angle this vector makes with the k. The z is the height of the vector.
You can take a print screen and
So-
add it on that picture.
Yeah. That might be better. This is x, this is y, this is z. If you look here, Karar, it's this part is the x, this part here is the y, and this one is the z. I, j, and k.
This is paint, right?
A program like Paint, my Paint, yeah.
Not the paint in the Windows.
No.
So you can paint it right there.
You might be able to. Continue?
Yeah.
Now, it's a little bit inconvenient to have to write vector or equals, 2 i's plus 3 j's plus 1 k or whatever. So for short, we can actually write the vector like this. 2, 3, 1. And this means 2 i's, this one here is 3 j's, and this one here is 1 k. So this is a lot easier to write. So you can say or equals x i's, y j's, and z k's. Yep. Now this is actually really good because it makes the process of adding vectors together really, really easy. For example, if I have vector or 1 is 2, 1, 2, and or 2 is, let's say, minus 1, 0, 3, and I ask you to do this, multiply vector or 1 by 4. So what happens to this vector? It gets 4 times bigger.
Yeah.
And then I say add this to twice vector or 2. You don't have to draw it. you don't have to do any parallelogram law. You can just go 4, 212 plus 2 minus 103. That's equal to 848 plus minus 206, which is equal to 6414. So the final answer is 6 i's plus 4 j's plus 14k.
Can I add that one?
Mm-hmm.
If it says multiply
Huh?
as R1 R2.
It will probably just say simplify.
Okay.
So there's no time here that we'll have to multiply matrices.
No, that's taken off the course. But we have something called dot product, which we'll do later. Yep. Okay. What I want you to do for me is I want the magnitude and the two angles this vector makes using the formulas I gave you earlier. Give it to me in degrees.
Got it.
All three answers? Yeah?
True.
Why are you looking at me like this? What did I ask you to get? The magnitude and the two angles. So all three answers. So you're not done. So leave your chips for a moment.
Got it.
Are you sure this time?
Yeah.
Right, so the magnitude will be square root 6 squared plus 4 squared plus whatever 14 squared is. Let's have a look.
196.
No, 196 I thought was... Oh, it is 196, yeah, thank you. 196 plus 16 plus 36. So square root that. So did you get something like 15.75?
260.
Yeah.
Yeah.
Now the theta, or sorry, the phi is tan inverse what?
Y over X.
Yeah, 4 over 6.
Yes.
33.6.
33.7. And then the theta is tan inverse z over the magnitude.
You said cos.
Oh, sorry, you're right, I said cos. $27.3 degrees.
Yes.
Yeah? Did you get that, KJ?
No,
What'd you do wrong?
I cannot use this. I
I
use
use-
one from the top.
I got all the same ones.
Which one?
That what our one.
Oh, no, I wanted it for this one. Okay, anyways. Can I go down? Yeah. Right, so here's something that should remind you of a problem in physics. Here is a vector, let's say its magnitude is 13. And its angle here is 60, the angle here is 67.38 degrees. And here is there's only I and J. There's no K here. I want you, let's call this vector here or. I want you to write or in terms of so many I's plus so many J's. Alright, I'll give you a minute here. I want the horizontal and the vertical component.
So this is I?
Yeah.
This is I.
Actually, I'll just call it A instead of or. No difference. You get it, second? How many I's? And J's?
And
Ah.
11.99.
12.
Yeah, so
Same as projector.
Huh?
The same as projector.
Yeah, it is. It is. So here, if you use your trigonometry, you can find that the horizontal will be 13 cos 67. Remember this from physics, mechanics? And the vertical, what would that be? 13 sine 67. Remember from basic physics? So that works out to be 5 and 12.
can I use the sine also?
No, don't do that. Just use what I taught you. The simplest way to do it, which is cos and sine.
So I said I use sine.
You said you used the sine rule.
The one, so cut over.
Ah, no, we don't call that the sine rule. That's not called the sine rule.
Nine.
The sine rule is a special thing. Remember it? And
Yeah.
cosine rule.
One
Yes?
over-
Yeah. Right. Now here is vector B, and I'll tell you what B is. B is 3I plus 4J. Now if you want, you can write these in brackets. So this is 512, and this here is 3,4. So that's B. Can you see?
Yes.
Correct. Can you see where B is? Do you see B?
Yeah.
What I want everybody to do for me is get this vector, AB. AB. From A to B. So vector AB.
Two y plus aj.
Almost.
So, I got it.
Are you sure?
Yeah.
What you get?
8I plus 16j.
Definitely wrong.
Mm,
Super wrong, in fact.
15I
No.
plus 48.
2i plus 8j.
Nope.
15I 48j.
No. What's the formula for AB?
Plus
A
plus
minus
A
y
and
plus a minus b.
My heavens, no! I should come over there and show you something. AB? What's the formula for AB? You did it like yesterday? Was it yesterday we did it?
Yeah.
Minus
Okay,
a plus b. B minus a.
B minus A. Fahad, do you remember this? What's the name of this rule? The rule that you did like in the last class that you forgot because you're not studying? What's it called? No. The triangle rule. Was it literally the last class? Was it the last class? Yes. Position vectors and triangle law. No, triangle law. Literally the last class and you forgot it. You see, this is why Connell and I are worried.
Oh, the a is b2.
From A to B.
Oh.
Come on, Tekken. AB is from A to B, and the formula is B minus A, which we did in the last lesson. So B minus A would be 3, 4 minus 5, 12, which is minus 2 minus 8, which is minus 2I minus 8j. So this AB vector, look, it's 2 to the left, and how many units down? 8 units down, because it's a minus 2I, and it's a minus 8j. So it's 2 to the left and 8 units down. As it should be. We expect both to be minus here, because it's gone left and down. This is why when I didn't hear a minus and a minus, I think your answers were all wrong.
No.
Yeah, but it's wrong, you know? Like if you run across the road and get hit by the bus and die, still got hit by the bus. Doesn't matter if you were close to not getting hit by the bus. And minus 2I minus 8j. Yep.
You want to see that? You want to do that in the experiment?
I'll watch, I'll thank you.
So there's still a lot to do in vectors. 1, 2, 3, 4, 5, 6. No, then there's statistics after that. Yeah. So there's 6 to do in vectors, and there's like 8 to do in statistics. It's okay. It's okay. The end might be a bit difficult. Yeah, well, it's really everything on the page. They're very short to do. Question 1 is just to draw. Question 2 is to simplify. Yeah, it's all straightforward. Right, so you've got a, what have you got now? Double EAP, isn't it?
Yeah.
Then we'll have an hour of maths later, 3 to 4. And then go home then. Alright, get out of here.